Hello students, today we are going to discuss about grade 10 chapter 1 periodic table, periodic properties and variation of properties part 4. In previous videos we discussed about atomic size, metallic and non-metallic character, electron affinity and ionization potential. In this video we discuss about chemical reactivity. The reactivity of elements depends upon their tendency to lose or gain electrons to complete their outermost orbit. So chemical reactivity is about the tendency to lose or gain electron. Greater the tendency to lose electron, greater is the reactivity in the case of metals. Similarly, greater the tendency to gain electron, greater is the reactivity of non-metals. Across the period, on moving from left to right, in a period, the chemical reactivity of element first decreases and then increases. Example, you take sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. First, sodium. Outermost electron is 1, the valency is 1. Magnesium, outermost electron is 2, the valency is 2. What about aluminium? Aluminium has 3 electrons in the outermost shell. The valency of aluminium is 3. Silicon, it has 4 electrons in the outermost shell. So the valency is 4. Phosphorus, 5 electrons in the outermost shell. It is in need of 3 electrons. So it gains electrons, 3 electrons. So the valency of phosphorus will be 3. Sulfur, it is in need of 2 electrons. So the valency of sulfur is 2. Chlorine, 1. The chemical reactivity is about the tendency to lose or gain of electron. Sodium has only 1 electron in the outermost shell and it will be very easy to lose that 1 electron compared to magnesium and aluminium. So reactivity decreases when you move from sodium to aluminium. But what about phosphorus, sulfur and chlorine? Phosphorus, the valency of phosphorus is 3. It is in need of 3 electron. Sulfur, it is in need of 2 electron. Chlorine, it is in need of 1 electron. So it will be very easy to gain 1 electron compared to sulfur and phosphorus. Sulfur and phosphorus in need of 2 and 3 electrons respectively. So the chemical reactivity is about the tendency to lose or gain of electrons. Chlorine has the more tendency to gain electron compared to sulfur and phosphorus. So chlorine is more reactive. So when you move from chlorine to sulfur and sulfur to phosphorus, the reactivity decreases. So on moving from left to right in a period, the chemical reactivity of elements first decreases and then increases. Chemical reactivity down the group. The tendency of losing electrons increases down the group since chemical reactivity in metals depends upon the tendency to lose electron. The chemical reactivity of metals depends upon the tendency to lose electrons. So the reactivity increases on going down the group. When you move from top to bottom in a given group, numbers of shells increases, atomic size increases. So it will be very easy to remove the electrons. The tendency to lose electrons will be increases. So the most reactive metal is present at the bottom of group 1. The chemical reactivity of non-metal decreases on going down the group. The most reactive non-metal is at the top of the group. So for metals, you take group 1 and 2 and representative elements, boron family. Okay. So the tendency to lose electron increases when you move from top to bottom. So most reactive metals present at the bottom of the group. But in case of non-metals, most reactive metals present at the top of the group. Gradation in physical properties. Down the group, melting and boiling point of metals decreases on going down the group. The melting point of non-metals increases on moving down the group. So oppositely related. So melting point and boiling point of metal decreases on going down the group. The melting point of non-metals increases on moving down the group. Across the period, physical properties, melting point and boiling point usually increases up to 14, group 14, and then decreases. A diagonal relationship, cut, is said to exist between certain pairs of diagonally adjacent elements in the second and third periods of periodic table. The properties which have increasing trends in a group generally have decreasing trend in the period. That is why elements of the second periods shows resemblance in properties with the elements of next group of the third period, which is present at the right diagonal of the element. This leads to diagonal relationship. So you'll be able to find the diagonal relationship when you check the properties between lithium and magnesium, beryllium and aluminium, and boron and silicon. What is actually atomic number? Atomic number gives the numbers of details about numbers of protons, and numbers of protons equal to numbers of electrons. Mass number. Whenever you calculate mass number of any atom, so you have to consider about the numbers of protons and numbers of neutrons. So this is overall summary. Non-metallic character increases when you move from left to right, but metallic character increases on top to bottom. Metallic character decreases when you move from left to right. Non-metallic character decreases from top to bottom. Electron affinity increases from left to right, decreases from top to bottom. Ionization energy increases from left to right, decreases from top to bottom. Electron affinity increases from left to right, decreases from top to bottom. Valence electrons increases by 1 when you move from left to right in a periodic table, and remains the same when you move from top to bottom in a given group. Thank you so much. Please subscribe my channel for more videos.